We've been asked to plot a polar point and then find 4 more representations of that polar point. In rectangular coordinates, we're used to plotting points, as an x comma y, as a go to the left or right so many and then go up or down so many. And so the point 3 comma 2, of course, is that point right there. And that's the only way to represent that point in rectangular coordinates. One of the coolest things about polar coordinates to me is that every point has infinitely many different representations. Instead of an x and a y, we're given a distance r and an angle theta, and that angle is measured in standard position, and the distance is measured away from the origin. So we'll start here by plotting the point 3 comma 5 pi 6 here on a polar graph grid. And so I know my point is 3 units away from the origin, so it's going to lie on this third circle out, 1, 2, 3. So it's one of these points here. And now I just need to rotate over to the angle 5 pi over 6. And so when I write my polar coordinate down, I'm thinking distance versus an angle. Honestly, when I'm drawing one, I kind of think about rotating to the angle first and then going out the right number of circles. So I'm over here at the angle 5 pi over 6, and I need to go out 1, 2 to a distance of 3. And so that's the polar point we're talking about through all of the different representations. That is 3 comma 5 pi over 6. But here in part A, I'm supposed to represent that point in a different way. I know r is positive, so well, that's going to be 3, but now my angle theta is supposed to be negative. So instead of rotating this way around to my point, I need to rotate the other way. And very quickly I can think about that being the angle minus 7 pi over 6. Just rotating past pi and up pi 6 more in the negative direction. Part B tells me that r is going to be negative. So it'll be a minus 3 rather than a 3. And if I think about what negatives do to that r, well, it means the angle I'm talking about is actually down here because the negative value for r reflects my point back through the pole. So I actually want to think very briefly about a point down here. I want to think about what angle ends up down there so the minus r will reflect through here. And in part B, my angle is supposed to be positive. So I'm imagining rotating around to 11 pi over 6. All right, next up, a negative value of r and a negative value of theta. So I'm rotating down here so that my negative value of r will reflect through the pole back to my original point. That'd be minus pi over 6. And then finally, I have a positive r, and now I just need this angle, but not stopping there, on the next full revolution around. So I'm thinking that that's just going to be 5 pi 6 plus a full revolution. All right, well, so 2 pi over, if I'm thinking about that with a denominator of 6, that would be a 12 pi over 6, so 17 pi over 6. And what I have here are 5 representations of that polar point, with only infinitely many to go if I wanted to write them all down. But that's it for now.